Hello my dear students, now we are having question number 31.9 of capacitor, and in this question it is given that a parallel plate capacitor shown in figure okay okay has plate area A and the plate separation D. Okay, so the distance between these two plate is D. The space between plate is filled up to a thickness D that is less than up to a thickness x that is less than D. Okay, so we are filling this thickness up to a distance x by a dielectric material having dielectric constant K. So we are filling this up to distance x by a constant K. Okay, now what will be the equivalent capacitance of this system? So definitely if we are just try to understand the concept with the diagram, so we will have two capacitance, one C1 and another C2. Okay, and these two capacitor will be in a series like that. Okay, will be in series like that. So what is this C1 and what is this C2? To find out the value of this C1 and C2, we can use the concept of parallel plate capacitor. So C1 is equal to epsilon naught A, but here the dielectric constant K is filled, so it will become K epsilon naught A, and the distance is x. The distance, the thickness is x. Okay, now same as it is C2 will become, because C2 will become now air field. Okay, we are not inserting anything in between this D minus x. Okay, it is still air field, so it will become epsilon naught A divided by D minus x. It is very important to understand what is the distance remaining, that is D minus x, and these two are in definitely in parallel. So 1 by C equivalent will be equal to 1 by C1 plus 1 by C2. This formula will help us to find out C equivalent. So 1 by C1 will be x divided by K epsilon naught A, plus 1 by C2 will be D minus x divided by epsilon naught A. Okay, so if you are taking this epsilon naught A common, so in the bracket you will have x by K, okay, plus D minus x. Okay, and that is equal to 1 by C equivalent. So what is this C equivalent? This C equivalent will be epsilon naught A divided by, okay, epsilon naught A divided by x by K plus D minus x. That is the final expression. If you want to take this x common from this two term, so this formula also we can write in terms of x minus x in the bracket 1 minus 1 by K. Okay, this is also very useful formula, not only for this question, for partial field capacitor also. Okay, this is formula whenever we are filling this capacitor partially, we are inserting any dielectric slab which is having thickness less than the distance between the parallel plate capacitor.